Hello everybody. So in the last video we come up with this we crazy insane expression. However, it still follow the rule, the basic rule, which is a plus b greater than or equal to 2 square root of ab. I just happen to pick a as this chunk and b as this chunk. Okay. But yeah, so hopefully the light is penetrating slowly, and now I will show you guys why would I do this, why would I do this. Okay, so if you add them together, okay, x1 squared plus x2 squared plus xn squared all the way to xn squared, they will have the common denominator, right? X1 squared plus x2 squared plus all the way to xn squared. That's the common denominator they have. And then if you add them together, what you have in the denominator, we have x1 squared plus x2 squared plus all the way to xn squared. Okay, this guy right here, well, let me write small. Okay, if you add them, it will be similarly y1 squared plus y2 squared plus all the way to yn squared over y1 squared plus y2 squared plus all the way to yn squared. Right, and then this will be greater than or equal to 2x1 y1 plus x2 y2 plus all the way to xn yn over square root of what, x1 squared plus x2 squared plus all the way to xn squared times y1 squared plus y2 squared plus all the way to yn squared. Okay, does this make sense? Okay, so yeah, I'm just literally add all of the thing we did together. So let's simplify this expression. So this one is what? You see how similar it is? Numerator and denominator is literally the same, right? So this is what? If a number divide by the same number, you get 1, right? Similarly, this guy is the same with 1 plus 1 greater than 2 x1 y1 plus x2 y2 plus all the way to xn yn. Okay, square root of x1 squared plus x2 squared plus all the way to xn squared y1 squared plus y2 squared plus all the way to yn squared. If you divide by 2 both sides, you have what? You have this is 1 greater than or equal to x1 y1 plus x2 y2 plus all the way to xn yn square root of what? x1 squared plus x2 squared plus all the way to xn squared y1 squared plus y2 squared greater than or equal plus on the way to yn squared. And then if you times the denominator both sides, you will get what? You get square root of x1 squared plus x2 squared plus all the way to xn squared times y1 squared plus y2 squared plus all the way to yn squared greater than or equal to x1 y1 plus x2 y2 plus xn yn. Okay, and if you square both sides, you arrive at x1 squared plus x2 squared plus all the way to xn squared times y1 squared plus y2 squared plus all the way to yn squared greater or equal to x1 y1 plus x2 y2 plus all the way to xn yn squared. Okay, and you know what is this? This is the Cauchy-Schwarz inequalities. I just show you how you got this guy right here. Yeah, so that is the proof for Cauchy-Schwarz inequalities. I know they're more general than this, but that's literally how you would approach the problem. You say A is this and B is this, and you just literally add all of them together and do some algebra manipulation. Like you say what I did here, divide by 2 and then times the denominator and then square both sides, and you arrive at a Cauchy-Schwarz inequalities. I mean, there's many proof for this. Some people prove by, they use matrix algebra, but my linear algebra is not good, and hopefully in the future when I master the concept, I will do a video when I prove this using linear algebra for you guys. Okay. You see how, but this is some textbook they write differently. So instead of writing this, they use the sum notation. So they will write something like this. Let me give you two variation. Actually 3. Actually 2. Okay. The first variation they would write is like this. They would write so you know how we say it and now gets so tired, we say x1 squared plus x2 squared plus xn squared, yada yada yada. It's so long, right? It just make our mouth tired. So they write the sigma notation instead, the sum notation. So they write like, first variation. They will write like what? They will write like sum of I equal to 1 to n xi square, right? This term right here is on this. Okay. Yeah, right. Yeah, that term right there is explained in the summation notation. And then later on they will move more crazy stuff, trust me. Okay, so and then similarly, oh sorry, I mistakenly deleted. Let me rewrite it. So sum of I equal to 1 to n of xi square. And then on this, right, similarly you can write like this, I equal to 1 to n of yi square, which is y1 square plus y2 square plus all the way to yn square, greater than or equal to sum of xi yi I equal to 1 to n all of this square. Okay, this is the first notation they write because they cannot say it on the freaking time. They cannot say x1 squared plus x2 squared plus and the way to xn squared, which make them already tired and their tongue, run out of water, stuff get dry, and that's why they say like that. I mean, okay, this is the first variation I know. Okay, and the second variation is like they write like this. They write this. They write sum of I equal to 1 and xi times I equal to 1 and yi greater than or equal to summation of y equal to 1 to n of square root of xi yi. Okay, square. Oh, my bad. Oh, yeah. No, it's correct. Yeah, so basically the same thing. So instead of xi, you write square root of xi. Yeah, so basically, if you want to get from the first variation to the second variation, it's very simple. I will leave it to the exercise for you guys to verify yourself, okay? So instead of writing xi, you would write square root of xi. And instead of writing yi, you write square root of yi. And then from first variation, you arrive at the second variation, like this one right here. Let me highlight in yellow. Color all of these, make them red, make them yellow, light them up. Yeah, don't do it, guys. Arsonist, saying someone house on fire is federal law. Okay, so I hope this video helpful, and I will see you hopefully in future video. I will do more, and I'm sorry for the length of this video. I hope you guys have a good night, and thank you for your interest.